Welcome, dear lovers of mathematics. I welcome you again to my YouTube channel, your YouTube channel, Learn Maths Iga Imibale. This is where you can get an ease. Here we have a non-homogeneous second order differential equation. Okay, and this equation is going to be solved in clear and correct way. Let's start with our question. Okay, we need to find an homogeneous solution of differential equation. Second derivative of y with respect to x minus 7 times the derivative of y with respect to x plus 12y, which is 0. Okay, to solve this, we assume the solution to be, we let y to be exponential of mx. So dy dx is equal to m exponential of mx. The second derivative of y with respect to x is m square exponential of mx. We are going to replace y by this, the first derivative by this, and the second derivative by this. Okay, and so forth. Yeah, we have m square exponential of mx minus 7 times m exponential of mx plus 12 exponential of mx, which is 0. Here, as you see, this equation is a factor of exponential of mx. That's why we are going to factorize by this. Okay, we have exponential of mx into m square minus 7m positive 12, and this is 0. This equation to be 0, it is sufficient that this is 0. This can be 0 for every value of x. This is always positive. That's why we equate this to 0. We have m square minus 7m plus 12. This is 0. We know factorization can solve this. Okay, let's factorize. You have m square minus 7 is the sum of minus 4 and minus 3. Let here minus 3m minus 4m plus 12, which is 0. Okay, we have m square minus 3m minus factorized by minus 4. Here minus 4 we have m minus 3, which is 0, and do it like this. Factorized by m, here we have m into m minus 3 minus 4 into m minus 3, which is 0. We have this is common, is a factor of this equation. You have m minus 3 into m minus 4, which is 0. It is clear that this to be 0, this first equation must be 0, can be 0, or this be 0. We have m minus 3, which is 0, m is equal to 3. m minus 4, which is 0, m is equal to 4. Okay, let's hope everything here is clear. Now, our homogeneous solution, which we write as YH, our homogeneous solution is equal to the constant times exponential of 3x, because our first term is 3, plus C2 times exponential of 4x, because our second m is 4. Here is a homogeneous solution. We need the particular solution, which is yp. We need a particular solution, which is yp. And to find this particular solution, we can use method of variation of parameters, where we use Gaussian method. But I will not focus on Gaussian. I'll be showing how to solve this differential by using discriminant method. That's what we'll be using. Okay, replace C by V. This is to say we have V1 times exponential of 3x plus V2 times exponential of 4x. This will be our particular solution. And here are conditions to follow. This is y1. Our y1 here is exponential of 3x and y2 is an exponential of 4x. Here are conditions to follow. Condition. Okay, the condition is that we differentiate this v's. v1 prime times y1 plus v2 prime times y2 is equal to 0. This is because you have two constants. Okay, we are going to differentiate y's. v1 prime y1 prime plus v2 prime y2 prime is equal to the right hand side stuff, which is this. Here is 4 times exponential of 4x plus x power 2. Okay, these are the conditions now. Yeah, as you see, our y1 is exponential of 3x. This is to say y1 prime, its derivative is 3 times exponential of 3x. y2 here is exponential of 4x. Here y2 prime is 4 times exponential of 4x. Okay, we are going to solve for v prime, v's prime in this condition. Hope you getting this. Okay, we have v1 prime times y1, which is exponential of 3x, plus v2 prime times y2, which is exponential of 4x. This is 0. Okay, let's write v1 prime times the derivative. The derivative is this, 3 exponential of 3x plus v2 prime times y2 prime is 4 exponential of 4x, and this is this stuff, 4 exponential of 4x plus x power 2. Okay, here we need to solve for v1 prime and v2 prime. Okay, here is using discriminant method. The discriminant will have these functions as constant functions. Discriminant is, we let the coefficient of this v1 prime is exponential of 3x. Here is exponential of 4x. Here are their derivatives, 3 exponential of 3x. Here is 4 times exponential of 4x. Okay, this is equal to, here is what? The determinant of a matrix, which is found by taking this times this minus this times this. Here is this times this is 4 exponential of 7x. Because the bases are the same, we sum up their powers. Okay, minus this times this is 3 times exponential of 7x. This is only exponential of 7x. Okay, let's find discriminant of v1 prime. This stuff will be replaced by this. Here is 0. Here is 4 exponential of 4x times x squared. Here is this exponential of 4x. Here is 4 times exponential of 4x. This is equal to, as you see, this times this is 0. We negate minus this times this. This is minus 4 exponential of 8x minus x squared times exponential of 4x. Here is dv1 prime. dv2 prime is, we like this, exponential of 3x. Here is 3 times exponential of 3x, and like this. The next will be this. Here is 0, here is 4 times exponential of 4x plus x power 2. This determinant is equal to this times this minus this times this. This times this is 4 exponential of 7x plus x squared times exponential of 3x minus 0. Okay. According to this, our v1 prime is equal to dv1 prime over d, and this is dv1 prime is this. Here is minus 4 times exponential of 8x minus x squared times exponential of 4x over d is exponential of 7x. This is equal to the exponential, this is minus 4 times exponential of x minus x squared times exponential of minus 3x. Here is v1 prime. Okay. v2 prime is equal to, it's dv2 over d. This is, dv2 is this. You have 4 exponential of 7x plus x squared times exponential of, here is 3x over exponential of 7x. This is equal to 4 times 1 plus x squared times exponential of minus 4x. Okay. As you know, when here is prime, this means we need to find the derivative. Okay. Let's hope you're getting this. We are here. This is what you have. So, since we know v1 prime is the derivative of v1 by with respect to x and is equal to minus 4 exponential of x negative x squared exponential of negative 3x. Yes. Multiplying everywhere by dx and dx here, and integrate. We have this and this will be simplifying one another. We said that with the integral of this derivative, which is v1 is equal to the integral minus 4 exponential of x dx plus the integral of x squared times exponential of negative 3x dx. Here, v1 is equal to minus 4 exponential of x minus, because here is minus, it has to be here x squared exponential of 3x dx. As you see, this integral requires to use an integration by part. Okay, as you see, here we have a polynomial and here we have an exponential. Let's do this. Let this as the derivative or differentiable, and here integral or integrable. We have x squared and here we have exponential of negative 3x. The derivative of this will be 2x, while the integral of this is minus 1 over 3 times the exponential of negative 3x. The derivative of 2x is 0, but the integral of this is 1 by 9 times exponential of negative 3x. Okay, this is why v1 is equal to, come back here, we have minus 4x exponential of x. Okay, now this is, we multiply this and this and this and this. Here is minus x square times this is minus 1 over 3 times x square times exponential of negative 3x. This times this is plus 1 over 9, sorry, 2 over 9 times x times exponential of negative 3x. Here is v1 prime. v2 prime, sorry, v2 will be the integral of this, okay, is 4 plus x square times exponential of minus 4x dx. This is equal to 4x plus the integral x square times exponential of minus 4x dx. As you see here, this also requires to use integration by part. Let's do it as we did here. We have d, we have I, okay. We have d is x square, where I is exponential 4 minus 4x. The derivative of this is 2x. The integral of this is minus 1 over 4 exponential of minus 4x. The derivative of this is 0, while the integral of this is, this times this is 1 by 16 times exponential of minus 4x. Okay, v2 is equal to, we have 4x plus this times this, x square times minus a quarter of my exponential minus 4x is minus, let's add, you have minus 1 over 4 x square times exponential of minus 4x plus this times this is 2x by 16, that is 1 over 8 times x times exponential of minus 4x. Okay, here is what we need. Our particular solution, which is this, yp is equal to v1, which is this. Sorry, v1 is that. We have exponential of 3x times v1, and v1 is minus 4x exponential of x. This times this is plus 1 over 3 times x square exponential of negative 3x plus 2 over 9 times x times exponential of minus 3x, okay, plus we are here exponential of 4x into v2, and our v2 is this. Here is 4x minus 1 over 4 x square times exponential of minus 4x plus 1 over 8 times x times exponential of minus 4x. Okay, yp here, a particular solution, this times this, we have minus 4 times exponential of 4x. This and this we have plus 1 over 3 x square. This power and this are of opposite signs. When sum them up, we get 0, and the exponential of 0 is 1. That's why we write only x square. And here we write 2 over 9 times x. Okay, let's come here. We have plus what? We have 4x exponential 4x minus 1 over 4 times x square. This and this will give 1 plus 1 over 8 times x. Okay, as you see, are there similar terms? This and this here is x. This times this, yes. Okay, this is similar to this. That's why this and this will be vanishing. Here, yp is equal to this and this. 1 over 3 minus 1 over 4 times x square. We have plus 2 over 9 plus 1 over 8 x. Here yp is equal to, we have 1 by 12 times x square. This plus times this is 16. 16 plus 9, that is 25, plus 25 over 72 x. Okay, our general solution, let's write yg, which is yh plus yp. The general solution will be, our yh is this. We have c1 exponential 3x plus c2 exponential 4x. Then we add our yp. This is plus 1 by 12 times x square plus 25 by 72 times x. Here is the solution to the differential equation we've been given. Now, I want you to thank you for watching. And I want to recall you that this question was from one of the university in Rwanda. I was given this by a student. May God be with you. And do not forget to subscribe on my channel. Know that your like, your share, your comment are very important to me. This is my time to remind you that I have a TikTok account which is Learn Maths. It has the same name as that of my YouTube channel. Go there and follow us. Thanks.